One reason we can change our brains simply by imagining is that, from a neuroscientific point of view, imagining an act and doing it are not as different as they sound. When people close their eyes and visualize a simple object, such as the letter A, the primary visual cortex lights up, just as it would if the subjects were actually looking at the letter A. Brain scans show that in action and imagination, many of the same parts of the brain are activated. That is why visualizing can improve performance. So this is the idea of simulation, that when we're thinking certain things, that we're simulating certain other parts of our experience, whether that is some motor movement or some other aspect of thought or some emotional response. All right, in 1904, he argued that thoughts repeated in mental practice must strengthen the existing neuronal connections and create new ones. He also had the intuition that this process would be particularly pronounced in neurons that control the fingers in pianists who do so much mental practice. The details of the imagining experiment were simple and picked up Cajal's idea to use the piano. Pascual Leon taught two groups of people who had never studied piano a sequence of notes, showing them which fingers to move and letting them hear the notes as they were played. Then members of one group, the mental practice group, sat in front of an electric piano keyboard 2 hours a day for 5 days and imagined both playing the sequence and hearing it played. A second physical practice group actually played the music 2 hours a day for 5 days. Both groups had their brains mapped before the experiment, each day during it, and afterwards. Then, both groups were asked to play the sequence, and a computer measured the accuracy of their performances. Pascual Leon found that both groups learned to play the sequence, and both showed similar brain map changes. Remarkably, mental practice alone produced the same physical changes in the motor system as actually playing the piece. By the end of the 5th day, the changes in motor signals to the muscles were the same in both groups, and the imagining players were as accurate as the actual players were on their 3rd day. Okay, so it's slightly slower for them, right? Oh, no. Okay, this is saying 2 different things. By the end of the 5th day, the changes, the muscles were same in both groups. This is a little ambiguous. The imagining players were as accurate as the actual players were on their 3rd day. So are they saying that after 5 days, the imagining players were as accurate as the other players were on the 3rd day, or were they both equal on the 3rd day? The level of improvement at 5 days in the mental practice group, however substantial, was not as great as those who did physical practice. But when the mental practice group finished its mental training and was given a single 2-hour physical practice session, its overall performance improved to the level of the physical practice group's performance at 5 days. Clearly, mental practice is an effective way to prepare for learning a physical skill with minimal physical practice. Just incredible. Doctors Yu and Cole showed that imagining one is using one's muscles actually strengthens them. The study looked at 2 groups, one that did physical exercise and one that imagined doing exercise. Both groups exercised a finger muscle, Monday through Friday, for 4 weeks. The physical group did trials of 15 maximal contractions with a 20-second rest between each. The mental group merely imagined doing 15 maximal contractions with a 20-second rest between each, while also imagining a voice shouting at them, "Harder, harder, harder." At the end of the study, the subjects who had done physical exercise increased their muscular strength by 30%, as one might expect. Those who only imagined doing the exercise for the same period increased their muscle strength by 22%. The explanation lies in the motor neurons of the brain that program movements. During these imaginary contractions, the neurons responsible for stringing together sequences of instructions for movements are activated and strengthened, resulting in increased strength when the muscles are contracted. This research has led to the development of the first machines that actually read people's thoughts. Thought translation machines tap into motor programs in a person or animal imagining an act, decode the distinctive electrical signature of the thought, and broadcast an electrical command to a device that puts the thought into action. These machines work because the brain is plastic and physically changes its state and structure as we think in ways that can be tracked by electronic measurements. So these had to be pretty simple signals. Moving your arm in a certain way or moving a finger up or down, like grasping, these are simple enough. Like, these are much more simple than a thought about a concept. What these imaginary experiments show is how truly integrated imagination and action are, despite the fact that we tend to think of imagination and action as completely different and subject to different rules.